terminology we need to be aware of. So parts of a circle. The radius of a circle. Oh my god.
It's the diameter, but half.
Describe to me. So I'm someone who's trying to.
It's from the middle of the circle to any outside. It's a straight line from the middle of the circle to the outside of the circle.
Okay, yeah. Now, I'm getting really clickety. Generally, we use the word centre rather than middle. Obviously, I know what you mean, but I'm getting fussy with you all to try and use the same terminology. So it's the distance from the centre to the outside edge. Okay, so distance from centre to outside edge. Okay, lovely, jubbly. And obviously your radius can go anywhere on your circle. It doesn't have to be where mine is. We usually label it with the letter R because we're really out there with maths. And we use the letter R to make radius. Diameter. We can describe the diameter. Yep, from where to where? Okay, so from one side of the circle to another, going through the centre. Excellent. Sorry I didn't show the centre on your circles. But I maybe you didn't have to show them the rest of them. So the distance from one side of edge to the other through the centre. Tread the ants. And what do you think we label this one? Oh, out there. Okay, I'm gonna. Alright, who knows what? This is a chord, not a chord. Okay, what's a chord? And not a musical one. One pardon? Lovely. Perfect. From one part of the outside edge to another. It's a straight line. Yes? So it's a straight line from one part of the circle edge to the other. I'm running out of space.
Without going through the middle?
Well, this is what I'm going to have a discussion about now. From one edge. Oh, this is where it's going wrong. To another. Apologies. So Emma just said it can't go through the centre. Yes, it can go through the centre. If it went through the centre, what would it be called? Diameter. Okay. So the diameter is a chord because it follows this description. It goes from one side of the circle edge to the other. Okay. So the diameter is a chord. Not all diameters, but not all chords are diameters. Okay. It's a special chord. And it's actually the longest chord. So the diameter is actually the longest chord because it goes through the centre. Okay, any other chord is going to have to be shorter than that.
But it wouldn't be called a chord if it went through the middle.
It would be called. Well, you could label it as a chord, but if you were asked to label the best description, you would say diameter. So they normally hedge their bet, so they'll say if they've asked you to label it for whatever reason, they would expect you to say diameter. But if you label it as a chord, you would be correct, but they would want the best description, so therefore it would be diameter. Does that make sense?
Okay, so
if you had a picture like this and they said label it, and you had in your list diameter and chord, you would be correct if you used either. But they would want you to label it diameter because that's a better description than the chord.
Is it like saying quadrilateral with a square?
Totally, yes.
Will they always have a center?
They should have a center. And tangent. Do we know what a tangent is? Ooh. No one? Oh, chord we don't really label because the D and R. So a tangent, no, we don't know. It's a straight line that just touches the circle edge. So, that's rubbish. We know that the ball is rubbish. Okay, so this secretly is touching it. So it's a straight line that just touches the circle edge. Okay, so it's a straight line that just touches the circle edge. Now, all of these descriptions, I probably should do this one earlier, because we keep saying circle edge, circle edge, circle edge. That circle edge is known as the circumference. So I've done that for you. I've done it in blue, so you can see that that's what the circumference is. So the circumference is the distance around the outside.
Can we just say outside the circle?
Sure. And you can also, I'm putting in brackets here, perimeter, because the perimeter of the shape is the distance around the outside. But basically, you need to just be aware that it's just a bit by the outside. Arc. Do you know what an arc is?
Is it a curvy line?
Is it a curvy line?
Like there's
Yeah.
also circumference.
No, like like a rainbow.
Like one portion of the circumference.
Oh my gosh, Jodie, I love your description. Did you hear what Jodie said?
It's like part of the circumference.
It's part of the circumference, yes. So anywhere you like, however big you like, you need to show that it's part of the circumference. They weren't the exact words they used, but they were hinted at, weren't they? Okay, so an arc is part of the circumference. Now, sector and segment, these are the two that people often get mixed up. Sector and segment. Sector and segment.
Okay. Not sure which one is which, but I know one is like a pie slice.
Which one is the pie?
So
Segment.
So one is the inside and one is the outside of the pie slice. No. Well, one's a pie slice. There you go.
The segment is the pie.
Jodie, which one's the pie slice?
I don't. So one of them is like the chord, and then from the chord to the outside of the circle.
Uh-huh.
The circle.
This is pie slice.
Okay, the pie slice is a
One is
segment.
pie slice and one is a chord.
Am I wrong now?
To the circumference edge. No, you're both correct.
Oh, what did you say?
I said the pie slice is a segment.
Oh,
Sector. And Jodie's is
unfortunately.
I just know what you were talking about.
So, the sector is this one.
perfect.
Okay, so the sector is this, and it comes from the center. Okay, so a sector comes from the center. So it's surrounded by two radii. Okay, so it's a piece of pie. You can describe to yourself what you want to describe it by.
Oh, there's segment. The other
And then the
part.
segment is as, and Jodie said, it's a chord, and then that part.
Would it be two radiuses with an arc? Or
Yes, I love that description, yes. Two radii, you would say it's radii when it's more than one. Two radii and an arc. The area surrounded by two radii and an arc. Love it.
love two radii. What is a radii?
Just radii.
Oh, okay, because I
Oh, I
was
put
around.
two radii and an arc. So it's the area surrounded by that, two radii and an arc. And the segment is a chord up to the circumference edge. So it could be that when you see some of these questions or some of these things, they might talk about minor and major. Okay, minor and major. So this would be a minor arc, this baby bit here, and this would be a major arc. Makes sense? Minor versus major. Because obviously with the circumference you got too big. And this would be a minor sector, this would be a major, and this would be a minor segment, that would be a major one. So just be aware that if they use those words, that's what they're referring to, the big bit or the small bit. Okay? I don't think it's worth necessarily doing anything about it. Okay, towards the end. So there's some terminology. Now, another useful thing to remember, you may look at these and go, oh, that's obvious, I remembered that completely. But if you have two radii, and then you're drawing this chord here, what kind of triangle have we formed? Isosceles. Because we know that these radii both come from the centre, but they're both the same length. Okay? So just be aware of that, that if you've got two lines coming from the centre, then you are forming yourself an isosceles triangle. Now that's going to be coming into play when you see pictures of triangles. When you see pictures of circles with angles inside them, you do need to try and remember those kinds of things as well. Okay? Let's move on. Now, essentially, I just picked these from a book because, quite frankly, drawing them all is just a pain in the bottom.
Y'all hear that? Okay.
So, is in the same way that when we had all those straight line angle geometry, we have the reason. Okay, so we need to remember the reasons, and then there's workings for them. Okay, so remember that the reason is not your working out. The reason is, for example, this first one, that the angle in a semicircle is always 90 degrees at the circumference edge. Okay, so if asked to give the reason for something, you would say angle in a semicircle. Okay, now I jumped through that. If we have a semicircle, okay, we can see that we've got this as our diameter. This angle here at the circumference will always be 90 degrees. Okay, you could draw that triangle anywhere and it would always be 90 degrees. So the angle at the circumference would be 90 degrees. But that's only in a semicircle. Okay? So if you saw a picture like this and they'd ask you to calculate this missing angle, you would just say it's 90 degrees. And the reason you would give is you would say angle in a semicircle. You don't need to say any more than that. You don't need to say is 90 degrees. You can if you want. Okay, but the reason would be angle in a semicircle.
So any triangle you draw, what angle would you then?
So from either end of the diameter. So it has to come from either end of the diameter.
Okay.
So if you had this is not 90 because that's not the center. Okay, if that had gone through the center, then it would have been 90. Because pardon? This one went through the center here because this is the center, but this one didn't. Yes. So it has to go through the center, yeah.
Then touch it then.
Well, if it goes through the center, it's going to be a diameter.
Okay. And the center means not really.
Yeah, obviously, I mean, the other half of the circle down here. Oh, that's
So the O is the center.
O is the center, yes. And that's generally what we label it as. So O you will normally see labeled as the center. Chords of a circle. Okay, chords of a circle. The perpendicular from the center of a circle to a chord bisects it. Okay, what do we think bisect means? Two equal bits, yes? So if we had a chord, any old chord, so here's our chord AB. Our perpendicular line coming from the center, so if this was 90 degrees, it means that this length here and this length here are equal to each other. Yeah? Totally interesting fact.
Wait, why are they equal to each other?
Because they would be equal to each other if this line is a perpendicular line. Okay, that's you. So again, if you'd had this diagram here, there's my center, here's a chord. If I had just drawn that little line there, these two lengths are not equal to each other. This one is equal to each other because this is a 90-degree angle.
Okay, and it'll give us something.
It will show you the 90
So this 90 angle is equal to the little parts?
Yes. So they're not gonna show you that those lengths are equal. But it might be that they may have drawn some triangles going on here. Okay? But you know that those two are equal, so these triangles are exactly the same. Yeah? So a lot of these things is you just have to look at the diagram and look for specific features of them and use that information then to work out missing angles. Okay, so they're not all necessarily going to be labelled. You just need to remember these things. Now you may have done some of these before. I'm not sure. Have you done any circle theorems before?
Totally. We did.
All right. So here is a circle. Okay. Here is my centre of the circle because it's labelled O. If I had any 2 points, so for example in this situation I call them A and B. If I were to draw lines to the centre, and from those same 2 points, lines to somewhere else on the circumference, then this angle here at the centre is twice this angle here. Okay? So if I've got 2 points on the circumference, if I join those 2 points to the centre, and those same 2 points to anywhere else on the circumference, then the angle at the centre is twice the angle at the outside. So for example, the question may be that they've labelled this 11 degrees, and asked you to find this one. What would this one here be? 22. Yes? So the angle at the centre is twice the angle at the circumference. Now, I just want to add an extra piece of thing there. Sometimes they draw them in a different way. Alright? So here I can see that here's my 2 points, I've joined it to the centre and the circumference up there. I might have drawn it? I might have drawn it this way. Okay? So, what can you see about these angles? They're both hanging down, yes? So they're both hanging in the same direction. So therefore, if I had drawn it this way, then this angle here and this angle here would have the connection. Does that make sense? Not equal, this one is twice this one. So if this was 100, this would be 200. But what I'm trying to get you to appreciate is that they have to be hanging in the same way. No, not really. Well, I guess kind of, yes. Kind of. They're both, yes. Just remember that they're hanging the same way. What I don't want you to do is to see a picture like this and say that this one, or this one at the centre is twice this one, because that's a load of rubbish. It would be the one above it, because they have to hang the same way. Yes? Yep. So this one up here is twice this one. Yep. Everyone happy with that?
So we would have to convert.
Not convert, but you would have to use your knowledge that they add up to 360 in a full circle.
So you would have to
convert. You'd have to calculate other angles. Yes. Okay? I don't know why, bless my heart, I think it's spaceships when I see this. I think it's because I watched Star Wars as a youngster, and these remind me of the little Star Wars ships. I'm weird. I know.
They're mountains.
All both sides.
They're not hot. Hannah agrees with me. They're not hot.
Most people are happier with the both sides. But basically what we've got here is we've got, again, 2 points on the circumference. We've drawn angles to another point on the circumference from both of those 2 places. Okay? It means that these angles here are equal to each other.
So the ones below are 2?
Which would mean the ones below are 2.
Could you draw like a line on the bottom?
If you wanted to. Yep.
if that's what you're hoping
These ones. Well, they would be because they come from C and D. Yes? Same situation.
Whoa.
Well, so if all 4 points are on the circumference, and they've made a bow tie, it means that the top 2 are the same and the bottom 2 are the same. But they're not all the same as each other. Yes? So the top 2 are equal to each other, these 2 are equal to each other. And what do we know about these 2? Why? What kind of angles are they? They're the opposite, yes?
Yeah. Wow. I feel like it's
So, now, just be careful because sometimes people are like, oh, bow tie, love it, love it, love it. And then they see something like this. And go, oh, there's bow tie, bow tie, bow tie.
But they have to touch the
But it doesn't,
circumference.
this one doesn't touch the circumference. Okay? This one actually goes to the centre. So this was the angle at the centre. This one's twice.
Oh my god, I don't think I can remember this. This is too much.
It's okay. I'm just gonna sound like yourself.
Now, I do actually have a little summary sheet with all the angle reasons on for you, so I will give that to you. I have to say, normally, I will ask you in a minute. Normally, I'm not a big flashcard fan for maths. I don't think it usually helps people that much because it's the process that you need to practice. However, for things like this, you do just need to learn the reason and the kind of diagram that you're looking at. So if you are a lover of flashcards, please feel free to draw yourself some flashcards and stick them around places because the only way of remembering these is just learning the picture, the kind of picture you've got and the reason. Yeah, and there are quite a few of them. Oh yes, sorry, your question. How do you mean the other way? Sure. It would be this.
What the heck? Hold on. I'm confused. That's not how you do it. As long as all 4 points touch the circumference.
I'm really sorry.
It looks like a bow tie.
This is a reason like that. Yes.
One word, it wasn't a bow tie just because it's center.
This one.
What is that?
So this one is the angle at the centre. Because from these 2 points, it goes to the centre, and from those same 2 points, it goes to the outside. But because it looks a bit like a bow tie, people jump to the bow tie reason. Okay? So whilst these diagrams will not be drawn to scale, so you will not be able to measure them with your protractor, most of the time you can generally suss out if they look the same as each other. Okay, so if the angles look equal to each other or not. And if it was drawn nicely with an actual straight line, you should be able to see that these 2 are not equal lines. And this is that one that I was talking about, the way that it's hanging. Okay, so just be careful. Sometimes they're sneaky and they'll go through the centre, but from these 2 points, it's still going out to the edge and to the centre, so these are all angles at the centre reasons. Okay, so these diagrams here are kind of special angle at the centre.
Wait, so that one, like
all 3 of these are angle at the centre.
oh, so
So this is talking about with the way that they're hanging. Yes, so that's the one that I was talking about earlier, yeah. So they both have to hang in the same direction. This one, it looks like a bow tie, but it's actually going to the centre to the outside edge. And this one here just happens to go through the diameter.
I knew that.
Yeah. Oh, yeah, so sometimes people just say, why is the angle at the semicircle 90 degrees? Well, it's a special form of the angle at the centre. Because if we drew a straight line across here to the outside edge for both of them, this one's going to be double that one. Okay, that's just a one side note. Oh, shush now.